Okay, everybody, let's start today's lecture. Okay, we have 50 people. At the end of the lecture, we reach a number of 100. That means that most of the people are coming late to the class is not because of the traffic or anything. It is because they are just late. They don't care maybe. Anyway, just a minute. Okay, so last time I think we talked about. I forgot my pen. Okay, last time we talked about flow of control, and I think this was the last position on the slides. Common pitfalls. We said that we should be careful about. Assignment operator getting confused with the equality operator. This one returns a boolean. Okay, this one returns a boolean. This one returns whatever is assigned, and sometimes we can, it is possible that we may have this mistake. So this is just a reminder. Okay, you already know this from your C++ C course. Okay, nested statements, they are all there. There is no difference between C and C++. I have two if statements, and I have my code indentation in here. Okay, so if you remember what we did at the beginning, remember our structured programming slide. I think it was at the beginning, like here, yes. Okay, so condition: if something happens, do this, otherwise do that. Okay, so this is another statement. In this case 15. Okay, good. So this is condition is speed is 55. If it is yes, then another condition, speed is 80. And if it is yes, then speed. If it is yes, then really. Okay, if it is no, then speed. Okay, so we don't know what happened here. We don't know because this part of the statement is just empty. So this is just called nesting, and nesting is possible with structured programming. Also, it is possible with object-oriented programming, and it is encouraged. We do nesting as long as it is correctly done. Well, when we do multi-way if-else, we don't keep increasing our indentation level. We don't say if blah blah, then if then something. Okay, do something, then else if blah blah, do something, then else if. So we don't do this indentation going all the way like that. Okay, instead our indentation is like that for this case of multi-way if-else statements. Okay, switch statement is there. It is exactly the same, no differences. You know about the switch statement. It is sometimes you need to compare this variable with lots of constants. In this case, I would use this. So if the vehicle class is 1, do this. If it is 2, do that. And it is very common that people forget about this break. If you forget about this break, what happens? Let's just read this code. Read this code and tell me what happens if I break, if I forget to put all those breaks.
Keep going, other case. Well,
Hold on a minute. Say that again. My volume was down. Yes.
keep going, running other case.
If case 1, if I hit case 1, I would print the passenger car and toll is 0.5. And then since I forgot the break, then I would print out bus, toll becomes 150. And I would print out truck and toll becomes 2.0. So wherever you enter the switch statement, it will continue executing all the cases if you forget the break. Okay. So forgetting break is not a compiler error. Okay, you may not write it, forget putting that break, but that's a logical error most of the time. Okay, so switch is a complicated statement and you know about it, and it's the same as in C++. A conditional operator, we talked about this. Sometimes people call this Turner operator. Why? Because it takes 3 parameters. Okay, it takes 3 parameters. This code, this piece of code here, and this piece of code are exactly the same. First, execute this Boolean expression, n1 is greater than n2. If it is true, then execute this one. This one does that too. First, execute this one. If it is true, then execute this one. Okay. Then assign it to max. Enis writes something. Enis, don't write anything in Turkish. Okay, so a conditional operator is the same, and as we said before, comma operator, okay, the ternary condition operator and short circuit and an OR operators are the only operators in C and C++ that guarantees the order of execution. Okay, comma says that left side will be executed first, right side next. Ternary condition says that the first side will be executed, this one. When it is executed, after that, okay, I will execute, depending on the result, either this one or that one. And this one says that I will execute on the left first. If it is true, I will execute right. This one says that I will execute the left first. If it is false, I will execute the right part. All the others we don't know. For example, this one, F1 G2. Before this plus, I know that F1 will be called and G2 will be called, but I don't know the order. I don't know if G2 will be called or F1 will be called. Okay. So and loops are exactly the same. We have the while loop, we have the do while loop, and we have the for loop. Okay, comma operator. I just talked about it. Okay. This one says that I will do this first. Okay, I will assign 2 to first. Then I will add 1 to first. Then I will assign it to second. After all of these done, okay, I will do this assignment. So the first get the value of 2 first. Then first plus 1 is 3, second gets 3. And this result of this operation will be assigned to first again. So at the end of this expression, both of the first and second will become 3. It guarantees the order of expression evaluations. Okay. Sometimes people forget about, or they are confused and they put a semicolon here. Okay. See this position? Semicolon. Well, this is not a compiler error. You are simply telling the compiler that if the response is not 0, I am going to be in the loop. And usually this is going to be an infinite loop. Usually this is going to be an infinite loop. Why? Because the while loop, the body of while loop is empty. You are telling the compiler that in the body of the while loop, I am not going to do anything. Okay? And I will keep checking this response. Okay? So the result is going to be infinite loop because nobody is going to change the default response value. Unless there is one exception. Okay? This may not be an infinite loop for some cases. Can you tell me how this may not be an infinite loop? There might be a case where this may not be an infinite loop. I know that, let's say at the beginning, response is 10, and after that I go to this while loop, and I'm running in this while loop because response is not 10, and my body of the while loop is empty. But I am saying that maybe this is not an infinite loop. Maybe something will happen. Do you know how?
Segmentation fault.
What? No, why would you get a segmentation fault? Why do you get a segmentation fault out of this? No. Everything I am doing is right. I am not doing anything out of the rules. Okay, everything is within the C and C++ syntax, and response is 10, and response is 10, and the while loop is depending on the response value. If the response is not 0, I will be in a loop. And I'm saying that for some cases, this may not be an infinite loop. Can you tell me a situation where I am out of the loop? Okay, maybe this is too early question. If you are writing a multi-threaded application, you have more than one executions at the same time. Okay, so you have a single program, single process, but there are two threads happening, two threads, thread number 1, T1, and thread number 2. In your thread number 1, you are running this, and in your thread number 2, maybe you are doing some assignments to response. Okay, so you are running two programs in parallel. The other program is modifying this response. In that case, you may be out of this loop. Otherwise, you are in an infinite loop. Anyway, ignoring this part, this is a bad code. Okay, this is a bad code. Why it's a bad code? Because if your intention is running an infinite loop, then don't put this semicolon here. Okay, put it underneath here. Okay, if you do this, you are telling the reader that I do this intentionally. Okay, and sometimes I would put a comment like empty body. Okay, you would put a comment like empty body. Okay, so this is something to be careful about. I am sure you know about this, but just we are repeating some stuff. Okay, this one is another infinite loop. Okay, this is a infinite loop, and whatever you do, there is no way you can be out of this loop. It will print hello on your screen infinitely many times, and it is a perfectly legal C++ and C program piece. Okay, sometimes we do this for some systems, for example, embedded systems, or your operating system, your main operating system. Windows, it is in a infinite loop. The main Windows program, it is in an infinite loop. It is like this. It is while true. Okay, while true. What kind of true is that? Sorry. While true. Okay, this is what you do. Get input dot dot dot. Get input means that get input from the keyboard or get input from the mouse or get input from the screen and process input. Okay. So basically many operating systems, including our Windows or Linux operating systems, are in such a loop. You get some response from the user or from the network, from some other I/O device, and I process it and I continue. Okay, and I'm in an infinite loop. Okay, and sometimes one of the inputs is shutdown input. In that case, I shut down the whole computer. In only that case, this loop is ended. Okay, so infinite loops, they are not illegal. You may want to have some infinite loops for embedded systems or for some parallel processing stuff, multi-threaded applications, but you should know what you are doing. Okay, so we have this break and continue statements for the loops. We know what they do, right? Inside a for loop, let's say this is my for loop, and inside the for loop, I have a break statement somewhere in there. So whenever I hit this break statement, I immediately get out of this loop, right? That's what the break does. How about continue? If I say the continue, if I say the continue statement, I will go back to the top of the loop. I will continue looping, but I will skip the rest of the body of the loop. Okay, these two things are legal, but we don't like them. We don't like them. Why do you think we don't like them? Somebody tell me why we don't like them. We say that if you have a loop, the loop should start naturally and should end naturally. Are you getting my? Are you fine now? Hello, are you? Are you hearing my voice now?
Yes.
So the question is, you heard what I said, right? Continue and break, they are valid and they are applicable whenever you want. You may use them, but we don't like them. Why do you think we don't like continue and break? That's what I was asking. Okay. If there are no answers from the class, then I will choose somebody from this time from the way end. Okay. Good. Okay. Zehra Aybala Ağırman. Zehra, tell me why I don't like continue and break. Zehra Aybala Ağırman.
I don't really know.
Well, you should tell me something. I don't really know is not a good answer. Is not an answer.
Yes.
Take a guess. It is not difficult. And I am just see this. It just tells you something. It just says natural flow. What is natural flow?
It's the default run of the program. I guess it's for example, it will the run of the program will go inside for loop and it will exit it when the condition is false.
Satisfied. Yeah.
But with continue and break, it will go out immediately from the loop, not when the condition is false.
Exactly. Why do you say you don't know then? I mean, this is exactly the answer. Because remember the first slide again. Slide number 3. This one. This is the structure of the while loop or for loop. I have a condition and I execute these statements. I keep executing these statements until the condition is not satisfied. This is the structure. But if you do the break statement, you are breaking immediately out of, let me use a red, out here and do this. And we don't like it. This is against the rules of structured programming. Okay. Well, this is not as bad as, and this is break. This is break. And this is, I guess, and this is continue. Okay. Both of them are bad, but they are not as bad as goto, because in goto, you may jump anywhere. With the continue and break, you know that you are around the loop structure, but with the goto, it is much worse. So don't use break and continue much. Okay. Sometimes if you need to, you may, but most of the time, if you end up using continue and break, think about your algorithm again. By the way, this break, the function of this break is very different from the function of the switch statement. Okay, switch statement breaks does something else. It just says that I am done. It is okay. But the break for the for loop or the while loop is different. Okay, good. Nested loops are possible, and we do that all the time. Here I have 2 loops, an inner loop, an outer loop. Okay. How many times do you think this cout will be executed? Tell me how many times the cout will be executed. This one, cout. Okay, everybody got their answers? Okay, people are saying 25. Why? Because this one will be executed for the index outer 0, 1, 2, 3, and 4. For 5, it will not be executed. For inner, it will be executed 7, 6, 5, 4, 3, but not 2, right? Not 2. So 5 values there and 5 values there, total of 25 executions. Okay, total of 25 executions. And the body of the outer loop is this inner loop, and the body of the inner loop is just single line. Since I have a single line, I didn't use this compound statement. Okay, and if you have a single line, don't use compound statements. This is not a good code. Okay, I don't like this code. Some people do it the other way, but I don't like it. If A, B, then they do this. B to D, else K to 1, something like that. Okay, if you have single statements, don't use these compound statement curly brackets. This is good enough. This is more readable. Okay. Don't use curly brackets if not needed. Good. Nested loops are, I'm not going to do it, anything more about that, okay? So at the end of this chapter, the book introduces the files. And as I said before, files are there in C++, but we process them a little bit differently. I am not going to give the whole details about the files. The details are in chapter 12. Okay, the details are in chapter 12. We are gonna see chapter 12. Either you are gonna read it or maybe TA will go over it. But now, for now, I will just show you an example how to process files, because in your second homework we're gonna process some files. Okay. This is how we do it. Okay, we say that this is a type of input. Oh, who's okay? Ömer, your microphone is on and it is making a noise. Okay, now you turn it off. Okay, good. Okay, so this is an object, this is a variable. The type of this variable is input file stream. Okay, so you make your variable. This is very similar to saying I have an integer, its name is A. I have a string, its name is B. Okay, so I have a input file stream object, input stream. Okay, its name is input stream, its type is if stream. So if stream is a new type, is a new class like a string. It is written by the C++ people and it became part of the standard library. Okay, to be able to use this if stream, you need to include f stream. Okay, file stream. Okay, so I made an object of it, and then this is how you open a file on the stream. You say that input stream.open. We did not see such a syntax before with the C++ language, but this is how you call a function on an object. Okay, this is my object or variable, and this is a function. You say that I have an input stream object and I am opening a file on it, and the name of the file is filename.txt. So in my current directory there should be a file named filename.txt. Okay, so this is how you open a file. In C, how we open the file? We said that fopen, right? That's what we did, and we gave the paths, and we gave a bunch of other options, and we assigned the returned value to a file descriptor. Okay, a handle. In C++, we don't do that. What did I say before? We don't like global functions in C++. This is a global function. We don't like it. This function here is part of this class if stream. Okay, so it's a member function. I think I did a similar thing with this string, right? Let's say I have a string. Its initial value is hello. Okay, this is how you do a string. Its initial value is hello. Then I can do b.size. If you call size function on b, it will tell you how many characters in there in b. It will tell you there are 1, 2, 3, 4, 5 characters. This is very similar to that. Okay. After I open maybe I should show you the whole program so that we look at the whole thing. This is the play.txt, filename.txt. Okay, in my current file, it looks like it's just a text file with 2 lines. One line is an integer, the second line is a name. So it says that the high score file. Okay, so the second line is a name, two strings, and the first one is a integer, and this is the program to read that file. Okay, so let's start from the beginning. IOStream is for see in and see out and that kind of stuff. Fstream is for the file, string is for the strings, right? Okay, so I'm saying that I am going to use name definitions from the std namespace, our main function. I have two strings, first name and last name, and an integer score. Okay, notice the coloring. String or fstream, they are not written in blue. Okay, they are dark. Why? Because the editor knows that they are not part of the language, but they are part of the standard library. Anyway, so how many variables do I have here? I have 1, 2, 3, 4 variables. This one, line 8, I know from C. Okay, these two I just learned last week or this week. This one I just showed you. Okay, so the type of input stream is fstream. Okay, once you define an object of a class, once you define a variable of a type, okay, there are certain operations that you can do on them. This is an object of class integer. Its name is score, and I can do stuff like score plus plus, okay, or score assignment 7. These are valid operations on variables of this type. Okay, on the variables of this fstream, there is a function named open. It is defined, and it is used for opening a file. Okay, once I open the file, okay, I know that I can use the stream extraction operator to read integers, also to read strings. Remember our file? Our file was like this, an integer and 2 strings. So this is what I did. Read an integer first and then read 2 strings. So you remember this operation, this operator, right? Stream extraction operator. Stream extraction operator is used for both reading from the keyboard, also reading from the files. Okay, so that means that it is overloaded even more. It is overloaded even more. It has many more meanings, And after that, I use my familiar cout object to print out the name, first name, last name, and end of line, and I put the score. Of course, as always, whenever you open a file, you should close it before your program ends. Okay, so this is just a simple example that opens a file, reads a single integer and 2 strings, and prints them on the screen, and ends. So how would you know what is possible with fstream objects? I mean, how did I know that open is defined and close is defined and that kind of stuff? You look at the documentation. Okay, you just look at the documentation from the C++ official pages. Okay, C++, you go to C++.com. Okay, in that C++.com, you either choose the class name from the left. Where are my class names here? Fstream. Well, maybe just type it in here, fstream. Okay, fstream is here, and with the fstream functions, let's look at this open. Okay, open is a function. If you click on, what did I do? Okay, open is a function. If I click on it, it will give me the open. Okay, It says that, let's look at the C++ 11 definitions, okay? It says that open takes two parameters. The first one is the file name. The second one is the opening mode. So there is a default mode. Well, I didn't give the second one because if you don't provide the second one, it says that it is for inputting and outputting, input and output at the same time. But there are many other modes in there. So I know how open works now. Are there any other functions other than open defined on this F stream? Yes, there are many others. Let's go to open again. Okay, see, these are the other things. Open, there is another one, is open. Okay, check if the file is open. Maybe the correct way to write this program is, after that one, maybe I should have done this. If input stream is open, then do this. Okay, so I put them in a block. So these line from line 11 to 16 will be done if the file is open. Why am I checking this? Because sometimes maybe if the player.txt is not on my desk, it's not going to be open, right? In that case, line 11 is going to give me a runtime error. Okay, runtime error. So I am checking if the file is open. If it is not open, then I will do this, else. What should I do? Tell me something. Else.
Create input stream.
Say that again. I didn't understand what you said.
Create a new input stream and make it fill.
You are saying that just keep trying again, keep trying opening. Well, I mean, it looks like the player.txt is not there, but I mean, that might be a good strategy, but I'm going to choose an easy one. I will do this. I will use the C error stream, okay? I will say file not found, okay? Then I will exit with a -1, okay? So maybe this is a better program because after line 10, maybe line 11 will not be executed right if the file is not opened correctly. Okay, so where did I get the information from this page? So all the functions on this F stream is described in this web page. There are many things. Okay, so let's see, I am not going to read all of them. I am not going to read some of them maybe, but there are many of them, and it looks like it's kind of complicated, but it is really not. So when you look at this kind of a page, you immediately know what is related to F stream. Okay, what is related to F stream. Okay, good. So this is one example of doing the files. Any questions? Okay, Yunus Emre has a question. Can we do cout score? No. Well, cout score and input stream, and then Yunus Emre, I don't know what you are trying to do. I mean, you cannot certainly do it, because if you do this, if you do cout, okay, input stream, if you do cout input stream, you are trying to print out a file descriptor, okay? This stream insertion operator needs a cout on its left, and it needs something printable on its right. And on its right, you are giving a file stream object. This operator is not defined on it. Okay. Well, you might be saying, okay, I am not doing this. You are saying that I am cout and score and input stream. You are saying this, but remember, this will return cout. This will become a cout. Now you are gonna do, once it returns the cout, it will be exactly same as this. I don't think that that line will compile. I am not sure if somebody has implemented this for the input streams. I did not see that in the, okay, let me see if it is in there. Stream insertion. Oh, what? Well, operator stream extraction, stream insertion is defined, but it is defined on this one as like input stream. So it needs the input stream on its left, not on its right. So that will not work. And I don't know what you mean by this question. Okay, any other questions? So if you run this program, it will print these Gordon Freeman, and the score is this. So that's the end of chapter number 2. We looked at the flow of control. Okay, we said that it is very similar to C, not much difference. And I have introduced a number of new things about C++, especially the file input. File output is very similar. File output is very similar. And you're going to read about file input and output in chapter number 12. Okay. One of the features of object-oriented programming is if you are not writing classes, if you are just writing a simple function like this, simple programs, it is very easy to use other people's classes. Okay. I have used this string class objects. I have used this fstream class objects. It is easy to use other people's classes if they are written properly. Very convenient way. You just make an object and you just keep calling their functions or use their operators. And how do I know about those functions and operators? You just look at the web pages, the documentation, and that's it. Okay, and it is easy to understand what is going on with this code, right? It is easy to understand what's going on in this code. Even without much explanation, you would understand what is going on with this code. The fstream class or type of fstream could be a very complicated type, but you don't care. You just use it. So Mehmet Hussein has a question. He says, is input stream extract up to a space? Well, if you do it that way, I mean, if you say just read me a string, it just reads a string up to a white space. If you like to read the whole line, there are other ways of doing it. For example, getLine. There is a function, a member function named getLine. GetLine reads the whole line. Okay. So the Hussein is asking a good question. He says that at line 12, when we said input stream extraction first name, how come the first name did not include both Gordon and Freeman? Because this works in a way that it reads up to a white space. Okay. Good. Okay, good question. So end of the chapter. Now chapter number 2, and we looked at this stuff. And if there are no questions, I will skip to chapter number 3, which is about functions. Okay, you think of your questions if you have any. I will go to chapter number 3.
May I ask something about the homework?
Sure.
Are we allowed to use dynamic data structures like dynamic arrays?
Enis, you did not attend yesterday's class?
I did attend, but I did my homework earlier, like first time you give it. I used my dynamic structures. So do I need to change it or can I keep
You
it?
did not attend yesterday's class?
I did attend.
So what did I say?
I don't really remember.
Somebody
Maybe I
asked this
missed
question,
that
maybe
part.
I spent like 5-10 minutes to explain. No, you don't. Okay?
Okay.
So you did your homework in a single day?
No, I just did the board part, like creating the game board.
Okay. Well, so it must be like 5 lines of code. Please change that 5 lines of code.
Okay.
Sir, board size will be 12, am I right?
Say that again.
Board size will be 12. It's fixed, am I right?
That's the
You
maximum.
told like
That's
this
the
yesterday.
maximum. And it has to be square. That's the maximum size. Okay? That's the maximum size. I made some changes to this chapter number 3 slides yesterday. So I am trying to get the... Yeah, so the maximum size is 12. That's why you don't need dynamic allocation. Just assume that the size is 12 by 12. If the user says that I am going to use 8 by 8, that's okay. Just ignore the extra part. Okay. Regarding, okay, just a reminder, okay? If you are getting some kind of a code from your friends or from your enemies or from some other place on web, okay? Even a single line of code means for us it is -100, okay? We will grade it as -100. No exceptions, okay? We don't care about your stories, and we don't listen to stories actually, because there are 150 different stories of this class. We don't know how those lines ended up the same. We don't know the story behind that. We don't know, you don't know the other people, etc. We never ask those kind of questions. It is just 100 and it is just -100. If 2 lines, even just 2 lines, is similar between 2 homeworks, okay? And there are other ways that we check these kind of similarities and cheating situations. Please don't do those kind of stuff. We don't like to deal with them, but if we see it, we are not going to ignore it, okay? We will have to do something. And most of the time I say this, somebody takes a piece of code from some web page. The other people, without knowing the other student, they take the same web page, and those lines end up the same, okay? So again, maybe there are other ways of having the same lines between 2 people that doesn't know each other. We are not going to ask much questions. We are going to just assign 100 -100, and we will continue. Don't do that kind of stuff. You may read lots of sources if you like. You may ask questions to your friends if you like, but don't get code from anybody. Okay, good. So let's start chapter number 3, functions. Well, you know most of the things about functions, but there are a few additions in C++. Okay. This is the structure of the chapter: predefined functions, programmer-defined functions, etc. Okay. Functions are basics of the C programming language. Since C++, okay, includes the C programming language. We have to deal with the functions, and we are going to write many functions in C++ too. But the thing is, we are not going to write global functions. We are going to write functions specific to types. Remember, there was a type named string. Okay. They have written many functions for the string. One of them is size. It returns the size of the string. The other one could be what kind of other functions I'm thinking of? Substring. Substring, let's say, start from character number 7 and 5 characters. Give me this substring. Okay, that's another function. There are many others now. I cannot think of other functions about string, but if I look at the documentation, I am going to see more than 10 functions available for this class. So we will write many functions, but these functions will be specific to classes. They are not going to be global functions. Okay, again, they are building blocks of C and C programming language. In C++, we're going to write lots of functions too. When you write a function, this is the important thing. What is the input? What is the output? And what does the process do on the input? So if you look at the function header, let's say this is a function header. It says that my function name is f, and I will take a double, and I will take a character pointer. Okay, when you look at the function header, you already know the answers to the input and output questions. My input is a double and a character pointer. My output is an integer. So what is the process? And process is usually is explained at the beginning of the function in a comment statement. This function does such and such and such and such. Okay, so that's the process. When you define a function, when you write a function, you always know about this information, and most of this information is included in the function header, and you have to write the function header in your header files so that the compilers can compile your programs properly. We already know that. Okay. The book says that, there are two types of functions that return a value, that does not return a value. Well, this is not a very good classification, but that's what the book says. And if you are using somebody else's functions, predefined functions, you need to include their header files. Okay. All the functions available for C is available for C++. Okay, including printf, scanf, and etc. All you need to do is just include their headers. Our C headers in C++, their names are a little bit different. Remember math header for mathematics functions? We have that header, but its name is CMath now. Okay, to be able to use a C math function like sine or cosine, you need to include this header now. Instead of math, it is C math. Okay. Instead of stdlib, you include cstdlib. Okay. So what you do is you just put a letter C at the beginning of the original C header file. This one is a new IO stream. Okay. IO stream. Remember we had a string header in C. Now we have our new string class in C++. For C string class, I include string. Okay. This is my include. This include is for C++ string. For the C string, you do this C string. Okay. But as I said before, we don't like to use C global functions much. So I am not going to include the C string much. I am not going to include the C stdlib much. Okay. I think I have a question. String is a type, it is also a function. How is it possible? String is not a function, Atakan. I did not say that string is a function. Where did you get that idea? Atakan, use your microphone. Where did you get that idea? Where did you get that line?
I try to hear my terminals.
I don't hear you. The meaning of that thing, okay, is not a regular function. You are building a new string object and you are printing it. You are printing it out. It's not a function, okay? Well, it's kind of a function, but it is not the function that you think it is. We will talk about it when we come to chapter number 5. String is the class name. Inside the classes, there are special functions called constructors. What you are calling here is a constructor, okay? And we will talk about it. Okay. Well, Nejat has a question. He says that, can I return a string from a function? Of course, yes. All new C++ types that you have created or other people have created, you may return them. Yes. If f function takes some parameters, returns an integer. This is possible. We all know that. Okay. And it is also possible to return a string from a function. It is also possible to return a fstream object from a function. Okay. So anything you can do with an integer, you can do it with a string. I can send integers to functions. I can send strings or fstreams to functions. Okay, we will talk about those later again. Okay, I think I talked too much. Let's take 10 minutes of break. It is 28 now. Let's come back here, 38. Okay, 10 minutes of break. Okay, let's start. So we have many predefined functions and we may call them.
Hocam sesiniz kapalı konuşuyorsanız.
Okay, so how did you know that I was talking? My camera was off. How did you know that I was talking?
I saw the screen, just the slide.
Okay, good. Okay, thank you. So I keep my Teams screen on another monitor, so I don't check it often. Usually it warns me that my microphone is off. Anyway, so there are many predefined functions and we may use them as we like we did in C. And here is one example. Include the CMAT header file. Okay, CMAT header file. And this CMAT header file includes lots of nicely defined functions that takes a double and returns a double. Okay, SQRT is a function that takes a double and returns the square root of that function. And we have been using this SQRT for the last year, right? For maybe 10 months. And it is very convenient. It is nicely written, very simple interface. You just give a double and it returns a double. Do you know how SQRT function works? Do you have any idea how it works? Binary search? Oh, okay. It's kind of binary search, maybe. Yeah. I think what Barış means is this. I think he's saying something like this. I'm just guessing. Let's say I have a number A, okay, and I like to find its square root. Let's say its square root is maybe A over 2. A over 2, I know it's not its square root. Okay, I calculate this number and I multiply this number by itself. Okay, to see it is the square root of A. If it is not, then I will try A over 4, depending on how big and how small it is. Something like that, okay? So, Barış, we don't call it binary search, but bisection method in numerical analysis. So, usually, these kind of stuff are implemented using numerical analysis techniques. Okay, numerical analysis techniques, they are they try some solution. If that solution doesn't work, it gives me an idea. It's something like that. It's something like that. How do you, let's say you have a function f, okay, this function is like this, and I like to find the minimum of this function. I don't know where the minimum is. So I start at one position. Let's say I started at this position. Let's say A. This is A and this is FA. Okay. I tried A. It is FA. Okay. And I tried B, a random position again. This is FB. Okay, I know that FB is closer to minimum than FA because FB is smaller than FA. So that means that maybe I make my search around this part. So I try this position or that position. Now around this part, this position, that position, and at the end I find the position where it is X. So I keep trying until I find the solution. So it's a numerical solution. And Barış is kind of suggesting maybe he's going to run some kind of a search. So it's not a closed form solution. It's a numerical analysis method. My point here is we never knew, okay, nobody knew, and actually I don't know how the square root function works, but we are using it without asking any questions. Okay, maybe we have wondered before how this thing works, maybe we did not, but we don't care how it works when we use it, right? So this is called abstraction, procedural abstraction. Functions are used for this purpose. I abstract away, I hide away the details of doing something, okay? I only tell the customer or the user of my function what I do. I say that I need, as an input, I need a double, okay? As an output, I will produce a double. The process is going to be the computation of the square root. And I don't have to tell anything else. I don't have to tell anything else. This is the abstraction, and we use this abstraction idea in many places in computer science. Okay, we abstract away, we hide away the details of doing things, so that the clients are not bothered with the details of the complicated stuff. Taking square root is a complicated stuff. Okay, but the user doesn't have to know about the complications. And as I said before, most of the time the user is myself. Okay, I am the user. Okay, even if I write the square root function myself, when I use the square root function, I don't want to remember the details of square root. I abstract away the details. And we are going to use this idea in many times. Remember, again, let's go to this string class. It's a very nice class. I know that I can define objects of it, str1 and str2, and I can do many things like the catenation operation, concatenation operation, right? Comparisons, less than, greater than, etc. And also I can take the size and etc. All of things are done for me if I make just appropriate function calls or the operator applications. Okay, I don't care how they implemented the string inside this class. That's what we are going to do. That's what we're going to do in this course. We are going to write these kind of classes so that the users of my classes, customers of my classes, do not know about the details. They don't have to know about the details. Usually, when they talk about object-oriented programming languages, usually they liken this to driving a car, okay? Driving a car. Okay, you have a car, you have an automobile, okay, and there are millions of people driving cars. All they know is there is a steering wheel, there is an accelerator pedal, there is a brake pedal. When you hit the accelerator pedal, the car goes faster, accelerates. When you hit the brake pedal, the car stops. When you turn the direction wheel, okay, the car changes direction. That's it. That's all you need to know, okay? Driving a car. Driving is a car, very simple. Hundreds of millions of people are doing that, right? They drive cars, okay? They drive cars. But how a car works is a very complicated, okay? Because there is this engine, there is this electronics, there is this aerodynamics going on when the car is very fast. There is this comfort part of the car, the stereo and the entertainment system and etc. Okay, those are all parts of the car. And there is this seats and security and the safety of the car. I don't know the details of how all of the things work. I mean, maybe I may know about the computer side of the car myself as a computer engineer, but I don't understand how the internal combustion engine works. Okay, I don't know the details. Even the program side, you know how many lines of code is running on a typical car? It is 80 million lines of code. Okay, 80 million lines of code. Okay, that's how complicated it is. But all I do in my car is I just open the door, close the door, start the engine, and hit the accelerator, and it goes. I know that. So they designed this car interface in a very, very nice way that many people can use it without much hesitation, without much difficulty. We are going to do the same thing with our software. We are going to design classes. We are going to design new types in a way that they might be complicated, but their usage will not be complicated. Okay? And we use this idea, actually, this abstraction idea, abstracting away the details when we do the functions. And square root is such a nice function. We never think about it, how it works, but we use it without asking much questions. Okay, good. So this is how you do the function call. These are very stupid basic stuff. This is how you call the function square root 9. I'm not going to talk much about it. And function calls can be, of course, mixed with the other statements like bonus gets the value of square root sales over 10.0. This is bad. 10.0. Okay. It's not 10, it's 10.0. Okay, I have a small program that uses a predefined function, IOStream and CMAT. Okay. I have a named constant here, 10.50, and I have doubles, 3 of them. I'm not going to tell you what this program does, but here is budget over cost per square feet. It's a named constant, it is uppercase letters, and I call square root. Okay, I call square root. By the way, square root is again inside the std standard library namespace, and then I do some formatting, fix point, show point to, and I print out this statement. I am not going to talk what this function does actually, what this program does actually. It's a very simple program, just an example of how you call a predefined function. Okay, inside the stdlib, okay, CSE241, we have all these functions, ABS, LABS. Okay, LABS is the absolute value of a long integer. FABS is the absolute value of a float. Okay, in fact, this FABS is defined in CMAT. Okay, so there are some confusions between the C and C++ libraries, even between the C++ libraries. I mean, these are very complicated things. We should not expect that they should be perfect, because these are all human-made. There are many mistakes, and what makes it worse is that from one version to another version, they say that, okay, we made a mistake before. Okay, we are changing the definition of that thing now to this thing, and we are deprecating the previous usage. That makes it even more complicated, but such is life, so we have to deal with those. Power, again, another function that is defined in the math library. We know this. It takes just 2 arguments. And there are some other stuff. SQRT, power, ABS, LABS, FABS. And with the examples, again, I am going to skip those. See, all of them, all of the headers, they start with this letter C. Right? So these are all C functions, and we should know them. Ceiling, floor, exit, random, srandom, seed, random seed. Okay, good. Okay, good. Predefined void function has nothing to do. It is not. I don't know what is going on with my internet connection, but it goes and comes back. Let me try to fix it. Where is my other? No. So I am connected using the wireless now, but my wired connection should be okay. I don't know what's going on with my wired connection. I think there is a problem with the switch. But I am both connected with wired and wireless at the same time. I mean, if one of them is gone, the other one should be okay. But it looks like both of them are going away and coming back. It should be okay right now, right? Can you hear me? Okay. Okay, so predefined function with the void, no problem. Okay. The void functions, they don't return a value. Our main function though, returns something, right? Usually we return 0. That means that we didn't have any problems. But if our main function returns, remember the previous example, I said that I print out a statement. C error something something something, then I exit my program with -1, right? So that is the error code from my program. My program is ending and I am returning an error code. Okay, you could do the same thing with your main function. From your main function, if you return a -1, that means that you are returning an error code. And how do you get this error code? In my case, in bash script, for example, when I say ls and I say echo $0, echo $1, ls this thing, I don't know. Do you guys remember how I get my error code? Oh, okay. Echo $, maybe question mark. Okay, yeah. So it is 0. Let me give it. Okay, this is an error. There is no file name df on my current directory, and that ls program returned me an error code of 2. It's not 0. But if I say it is hello cpp, okay, now what is my error code? This is 0. So this is how you get your error code. So this is echo 0 is not correct. It should be echo $, question mark. Okay. So whatever you return from the main function is passed to the operating system, and depending on your operating system, there should be a way of getting your error code. Okay. In my case, it was $, question mark. Okay. Your programmer defined function is the basic thing, the fundamental thing that you do with the C programming language. In C programming language, all you do is writing functions and calling the functions from each other. Okay, and usually they give you some principles for writing functions, such as they say that, okay, your function should be readable, it is reusable, okay, and you're going to use divide and conquer technique. What do we mean by that? Usually our programs are very complicated. For a very complicated program, you don't write a single function. You write many functions, and functions, they call each other. Okay, they call each other. You have a main function. Okay, that main function calls function number 1, function number 2, function number 3, and that function number 2 maybe calls function number 5 and function number 6, etc. So you structure your program in this way. It's like a tree. Sometimes it's a graph, because sometimes it's function number 5 calls function number 1, right? So divide and conquer says that divide your task into smaller patches, nicely defined patches, nicely defined functions, and implement each function by themselves and call them. Okay? And some people say that your functions should not be no longer than 30 lines. Okay? If your function is longer than 30 lines, then you are doing something bad. You are doing something, you are trying to do many things at the same time for a function. And if you try to document what that function does, probably you won't be able to explain it in Turkish or in English. So your function should not be longer than 30 lines. Okay, the number of parameters, it should be less than maybe 4 or 5. Not many parameters you should not take, okay? You should not take many parameters. That means that you need too much information from outside, okay? So there are these kind of principles, there are these kind of guidelines for you to write good functions, okay? If you follow these, okay, you will end up writing a nice structured C program, okay? Nice structured C program. And some of these functions will be actually very useful functions, not for you only, but also for the other people or for the other projects. So you put them in different files so that they can be used by other people. They separate the file so that others can use it too. Okay, so these are the programmer defined functions. And function declaration, how it is done is exactly the same as in C. There is no difference. You will say that this is my function name, and this is my return type, and these are my formal parameter list. Total cost is my function name. I will return a double. These are formal parameter list. Okay? And in C++, different from C, without defining the function header, you may not call it. Okay? In C, it was possible to call a function without definition, but function declaration is defined. Implementation will not be defined to call it. Implementation will not be required to call it, but function declaration is definitely needed. By the function declaration and definition, I mean the same thing, okay? Implementation is different. This is function definition. This is function declaration. All I'm saying is that to call this function, I need a double and I need an integer. I will return a double. The compiler needs, C++ compiler needs this information. It needs this information. Let me try to... Now I am using the wireless connection. Let me see if I can get... No. Yeah. Maybe I will get the wired. So I get the backup. Okay. So both of them are available now. Okay. So before any calls, I have to have this in C++. This is different. In C, you don't have to have it. That's why I asked that question last time. Without including the stdlib, you may call printf or scanf, and somehow it works out of coincidence or that kind of stuff. But in C++, you will get an error message. Without compiler, without saying this line, you cannot call the total cost. Just try this, okay? Just try this with your GCC compiler and G++ compiler. Okay, here is one function definition. There is no difference from C or formal parameters, return thing, and I do my calculations and I return something. Okay, I return something. By the way, I don't know why they put this parentheses in there. You don't need those parentheses. Okay. Again, your function definitions should be in your files. Where should I put my function definitions? Usually we follow the same rules as in C. You do this, okay? You do this. This is your file. Let's say this is my program .cpp. These are your includes and other compiler directives. And then you say that I have a function named f. It will take integer. Another function, it will take a string and return a double. Your function declarations. Then your main function. In your main function, you will call f and you will call g, and your main function will end. At the end of your file, you will make your implementations. Int f, int k, such and such, double g, string s, such and such. Okay, so this is usually how you put your implementations. Okay. Why do I prefer it this way? I prefer it this way because in my main function, I know that I will call this one and that one. But main function does not need to know how the f or g is implemented. The main function, all the main function needs to know is f takes an integer and g takes a string. Okay, and f returns an integer, g returns a double. This is what main function needs to know. So I give the main function whatever it needs to know, but during the runtime, during the execution, of course, when I call function f, I have to have the code for function f. I need to run it. So these two implementations are needed for my executable program, and they will be compiled together. Okay. Okay, this is the idea. As I said before, we don't do many global functions in C++, but the idea is the same as C. Idea is the same as C. Usually we don't put many function implementations in the same file. What do we do instead of doing this? Okay, how do I like to add, okay. Here, I like to insert a page, and I want to find how to insert a page. Annotations, page manipulation, maybe insert a page. Okay, good. Insert a page after that, good. Did I insert the page? Yeah, I have an empty page now. Let me copy this. Control C and duplicate. Control C. Oh, okay, it worked. So usually I don't do this. What I do is this. This is my prog.cpp. I say that I will have a header file. Right? Let's say my helper functions, helper.h. Inside this helper file, helper.h, I have the function declarations like that. Of course, there are some guards in the header helper file, and then in my helper.cpp I have the implementations of these functions, and of course I would say include helper.h, right? And in my main program prog.cpp, what would I do? I would include helper.h, and I would write my main function, and main function would be best, right? Let me copy it from here. Okay, so this is my main function. Okay, this is how I do. So I have two files to compile. How do I compile this? I would compile g++ -c prog.cpp and g++ -c helper.cpp, and then g++ -o prog and helper.o prog.o. This is how I compile it. Instead of doing this, instead of doing this, I would do this. I mean, instead of doing it with one file, I don't do that. I do it with 3 files. Why? Because in case that I like these functions f and g very much, in that case, I like them to be available for anybody else. I mean, I may use them in other places other than this prog.cpp. Okay. Ozan has a question, and I don't know when he asked that question, and I don't know what he means. I lost the context, Ozan. Can't we do it at the same page? What page? Ozan asked the question. Use your microphone. Ozan, I am listening to you.
Can't we do helper H and helper CPP at the same page?
At the same file, you mean?
Yes.
Well, if you do it at the same file, then when if you are gonna do it in the helper.h, you are saying that implement these functions in helper.h, okay, and include it. If you include it, you would include the implementation too. Including the implementations is not a good idea, because if you include them in more than one place, that's going to be bad, okay? And you like to separate your interface from the implementation. This file is only for interface. This file is about how you use those functions, okay? This file is not about how the implementation works, okay? Implementation is hidden away at some other place, okay? This is the customer of helper functions. Prog.cpp is the customer of helper functions. For this function, for this file to compile, all it needs is this information. Okay, all it needs is this function declarations. Okay, it doesn't need anything more. As a customer, I don't need to see the implementations. So to be able to compile and run this program, all I need is this program itself, also the object code of the helper.o, okay? So if somebody gives me helper.o, I will compile and link with my prog.o and my program is going to work. So I don't need to see the implementation. Usually we like to keep them at different files. Keeping them in the same file would be the same as this. So your fng depends on the main function and etc. So I am trying to separate them so that maybe I can use fng at some other project other than prog.cpp. Okay? Question for you. C++ question. What happens if I just erase this line? I erase this line and I am trying to execute these three compilation executions. What happens if I erase that line? So Mehmet Hüseyin says that don't recognize functions. So I would get a compiler error when I try to compile prog.cpp, right? Because how does the compiler know about F1 or G, A, B, C? What is F? Okay, so in C it is not an error. It's a different problem, but it's not a compiler error. It's a bad thing. I mean, for both and C, not including that header is a problem. For C++, it's a compiler error. For C, it is not compiler error. So this is a bad thing. This is a bad thing that it happened. How about this? What happens if I erase this line?
It's compiled, I guess, but we can't get any result of the functions.
Hüseyin says that it would compile, but we would not get any results. Any other yeses? Yeah, the answer is correct. It would compile, and it would compile just fine. That's true. I mean, it would compile, and it will compile fine. It will run fine. Why? Because this helper.cpp, it just says that, okay, it just says that I am declaring and implementing two functions named f and g. Okay, so it makes it available in this object code helper.o. When from the prog.cpp, it says that I need two functions f and g defined somewhere, and it gets that information from here. During the linking phase, it will find its implementations. So you actually, for the compiler, you don't need this line here. Basically, you don't need it, but we include it anyway because by mistake, if I do such a thing, let's say, by mistake, if I say instead of typing int here, I type, let's say, double or string, something like that. This and this will be in conflict, and compiler will give me an error message. So by including this file here, okay, I am making sure that helper.h and helper.cpp are compatible. They are talking about the same function. Okay, same function. So in your homework, I encourage you use more than one file to do your homework, and try to separate your files as much as possible. Write small functions, not large functions, small functions, at most 30 or 40 lines of code, and include many comment lines. Okay. Nejdet, you said not include main function, and I don't know what you mean. Not include main function. I don't know. 3 minutes ago, I don't know what that means. So function calls. Okay, we know how to make a function call. Okay, total cost and provide to the data that the total cost needs. Okay, the arguments could be variables or the constants or expressions, and they all will be dealt accordingly. Okay, here is one example again. Total cost, I mean the function declaration, then I call the function here, okay, and implementation is at the end. Okay, it's a simple stuff. I will not talk much about it. Okay, declaration is information for compiler. That's what we said before. The compiler knows, without seeing this declaration, compiler cannot produce code to call this function. Okay, without seeing, if I erase this line, let me erase it with red. If I erase this line 3, this program will not compile. This program will not compile for the C compiler, because the C compiler will say that I don't know what total cost is. Okay, I don't know what total cost is, even though it is declared and implemented after the main function. The compiler will say that I did not see what total cost is, so I am not going to compile it. But the C compiler compiles it. Okay, C compiler compiles it. How does the C compiler know how to call this function, total cost? How does the C compiler know? Because C++ compiler say that I don't know how to call it. I don't know how many parameters this total cost takes, and I don't know what it returns. How am I going to call this? C++ says. C says that okay, I will call it. So how does the C compiler know how to call such an unknown function? Any ideas? Any ideas? Atakan says that should we use H files? Yes, should. Yes, you should. That's what I said. Try to use as many functions as you as much. And if you have so many functions, you put them in your header files and try to make them reusable. Yes. Okay, so you answer my question. How does C compiler know about total cost if it didn't see any definitions of it? How do I call it without seeing the definition? I don't know the return type. I don't know how many parameters it takes. No, Mehmet Hussein, it doesn't do that. No. It compile from and no. Well, it is not. It is against the whole language rules. I mean, in C, when you compile a program, you start from the line 1, line 2 or 3, and when you compile your main, these are the first lines to compile. Okay, so you know about price and bill and number. Okay, it doesn't do from even if I don't have this declaration and definition and implementation, this file would still compile. It would not link, but it will still compile. So the assumption of C is this: if there is a function call, let's say f something something, it says that if I had seen this function declaration before, I will do the type checking. But if I did not see it, I will assume this function will return an integer. Okay, that's my assumption. This function returns an integer. For the types, okay, I will not do any type checking. I will turn off type checking. I will turn off counting the number of arguments. Okay, that's the assumption of C. So when this total cost compiles, the C compiler assumes that it will return an integer, but it says it returns a double. So it will try to assign this double to an integer. Okay, So there will be a problem there. Okay. And the arguments that you are sending, they will not be type checked. They will not be type checked. That's why even if you did not include stdlib and use printf or scanf, they kind of worked, because usually we send correct parameters to printf and we ignore the integer returned by the printf. Okay. So that's how C behaves. C is a very flexible language actually. Okay. So I think I am out of time. I will stop at this point, but I think you have a few questions. Does it compile from and to? No. Hussein Ömer, he says that it's return 0 auto. What? Are you talking about line 22, Hussein? Is return 0 auto? It's return 0 auto. I don't understand what that means. Why don't you guys ask implicit declaration? I don't know what that means. Is pre-declaring functions before the main and declaring them after the main essential, or do we do that just for good syntax? Yes, exactly. We do it for just convention, because people are doing it that way. Usually we declare them and after that we implement them. Okay. Can we just implement the whole function before the main? Yes. We don't call it can we declare. We can implement it. You can copy paste this lines 24 to 30 just at this position, line number 3, and it should work. But usually we don't do it that way. We like it this way. Why? Because our prog.cpp should be simple. Before the main, I don't want to see anything complicated. All I wanted to see is what kind of header files I need. After that, I would concentrate on my main. And same thing in here. What kind of header files I need, and I concentrate my task. Okay. I don't do detailed stuff at the beginning. If you want to do everything in a single file, then do it this way. Declare them first, use them, and implement them. So that later you can take these parts out and put them in their own files. Okay, put them in their own files here. I put them in there, and I put them in the header file. If we don't declare anything in the function, then there's be an empty function, Hussein. If you have two functions before the main function, can these functions call each other? Why not? Are you saying that? Okay. Here F can, of course, call G with a string A, B, C. And here G can call F with an integer. No problem. Why? Because when I am compiling this line, I know the declaration of G because it is here, right? It's there. And when I am calling function F, I know the declaration and implementation of F. It is possible. Maybe Atakan is trying to say that if we didn't do it this way, function F cannot call function G. Okay? If I didn't do it this way. Maybe he's trying to say that, but I am giving up what you try to do, what you try to ask by typing in there. Hussein, I don't know what you say. I don't think that you know what you are saying. I mean, if I read that sentence, it's not even a sentence. So if you have those kind of, for simple yes no questions, ask them. But if you're asking those kind of questions, use your microphone. Okay, that's it for today. I will see you on Monday.
Hocam